Hey, Mr. Boer here for online chemistry as we do, and we focus in week 4. We're going to look at chapter 9. This is going to be some review stuff and some new stuff as we start to get into the last couple of weeks here. Chemical names and formulas. And what that is really called is just nomenclature. So we usually just say chemical nomenclature, which means we're going to be naming formulas. Well, in order to name formulas, you have to be able to figure out 3 types of compounds that you would have. They all have different rules. So the first type is an ionic compound, chapter 7. Second type is a molecular compound held together by covalent bonds. That was chapter 8. And then we're going to be introduced to acids and how to name them. And that's really all we're going to look at, just introduced to acids because they have a little bit different way to name them. Now, bases are going to be named just like regular ionic compounds, so we don't have to worry about it. So be able to figure out what type of compound it is. And to review a little bit real quick with you, if it's an ionic, chapter 7, it was going to be always a metal. It's always going to start with a metal, a positive, a cation. And then it's going to end with some type of negative, which would be the anion or the nonmetal. But it could also be a combination of atoms. That's polyatomic ion. Poly means many. Atoms that still have a charge. It's kind of a combination of covalent and ionic, and we still name it by the ionic compound. So as long as it starts with a metal, it'll be ionic. Covalent, which is a molecular compound, always had 2 nonmetals or 3 nonmetals or vice versa. It was all nonmetals. It never had a metal in it. And then we need to be able to identify what an acid is. And the easiest part of identifying an acid is the fact that it starts with an H. Hydrogen is acting as a metal when most of the time it acts as a nonmetal. So if H comes in first, it's the first part of the formula, you know it's an acid. Naming of ionic compounds can be exactly like we did in chapter 7. Once you identify it as an ionic compound, it's going to start with a metal, you never change the name of the metal. Okay? Just like when we said sodium ion, if it was Na+1, we'd say sodium ion. You take the word ion off, but you just still say sodium. If it was the nonmetal, it ended in "ide." So sulfur would be sulfide. So we just put those two together. If they form an ionic compound, we'd say sodium sulfide. If it's a polyatomic ion, it will be more than 2 elements. Start with a metal and may have 2, 3 nonmetals. Those are going to end in ate or ite, and we'll look at those in a second. So if we look at just a couple of them, as far as being able to know those polyatomic ions, just memorize them. I know it sounds weird, but just be able to memorize them. If you look at nitrite there with an ITE ending, that's NO2, and pay particular attention to the charge. The charge is going to help you when you go back and write them. And nitrite, nitrate are both -1. If you look over on the other side of the table, you have sulfite and sulfate that are both -2, and then you could have some that are -3. You're just going to have to memorize that chart. So if we look at how to name them or how to write the formula, this is exactly like this is the crisscross method that we did. So if we look at potassium here, we have to first figure out what's its charge in symbol. So it's K+1, just like you did in chapter 7. Sulfide was S-2. So we had to crisscross because they didn't match up. So it'd be K2 subscript and then just S1 when we knock the one off. So it'd just be K2S. Calcium phosphate, going to do the same thing. It's a metal. So we need Ca. It's a 2+ charge. Phosphate, look at the ending. Got to go back and see, okay, phosphate, is it on here? Oh, yeah, phosphate's PO4 with a 3-. The minus is what we're going to end up then going to figure out if we have to crisscross. Well, calcium was +2, phosphate was -3, so we crisscross them. Ca3 with a subscript, and then you have to put in parentheses phosphate, which was PO4. That's what phosphate is. And then we put the 2 after the parentheses. Now, if it's lead is not it's a post-transition. We don't know the charge of it like we do some of the representative elements like calcium, potassium, sulfur, phosphorus. Lead is going to be, in Roman numerals, they're going to tell you the charge. It's 4. So it's +4. Chlorine is a -1. How do I know it's just chlorine? Because of the IDE ending. So we would crisscross it. And the same with ammonium nitrate. When you go the opposite way in naming, again, figure out if it's a metal. Sr, strontium's a metal, aluminum's a metal, chromium's a metal, titanium's a metal. And you just name the metal and then change the ending to ide. So